Assalamualaikum again, insyaAllah. We will continue with part 2. Everybody can hear me? Just drop a comment just to show that you are here for the second session. Okay, you can remind the others untuk nak masuk juga. Ada 12. Hopefully boleh bertahan lagi dalam 50 minit lagi lah 45 to 50 minutes sebab this set question agak tough lah kan for everyone basically. Okay, insyaAllah we'll proceed. So this is part 2 of superposition. Kalau part 1 dia main dengan standing wave, part 2 the core is on the diffraction lah the diffraction and the diffraction grating. Got either one source, a single source, single slit diffraction, got a double slit, dan kita ada diffraction grating kat situ. Okay, if you have any questions, feel free to ask in the comment section. So we'll proceed with the multiple choice questions. Number 1, diagram shows water waves passing through a gap. What property of waves is being demonstrated? The answer is diffraction. And okay, just a few terms for us to clarify. Number 1, diffraction, spreading out of waves after passing through an aperture or meeting an obstacle. What about interference? When you have two sources, two or more waves meet at a point, there is a change in overall displacement and intensity. It's either constructive ataupun destructive. As for superposition, the definition of the principle of superposition is the resultant displacement at a point is equal to the sum of the displacements of the individual waves at that point. That means each particle dekat wave tu kita akan kira dia punya superposition. What about polarization? The process of transforming unpolarized wave into polarized wave. Maksud dia apa? An original wave that is vibrating in more than one plane, in one direction. Kalau contoh yang hari tu kita ambil ialah electric and magnetic fields. Then kita go through a polarization process. As ada polarization slit. So dia akan only vibrate in a single plane. So for this question, the answer is A. Number 2, the diagram shows two loudspeakers connected to the same signal generator. A girl walks from position A to position B. Which statement describes what she will hear and gives the correct reason? So kita tahu it's a straight line. So we've got two coherent sources because it originates from the same generator. So kita akan ada interference. So with interference, the diffraction will have nodal and antinodal lines where it will become loud and quiet lah kan, alternatively. So the two loudspeakers generates two coherent sound waves that intersects between each other. In between A and B will be an alternating loud and quiet fringes. Fringes lah kan, sebab kalau fringe ni kita boleh nampak lah kan, dekat dia punya, kalau dia light source lah kan. Cuma yang ni dia sound lah kan. So kita boleh dengar je. So due to constructive and destructive interference occurring along alternating antinodal lines and nodal lines respectively. So the answer is A. So of course lah, steady loud sound or steady soft sound, C and D is out. Yang ada option yang kita nak jawab ialah either option A or option B, betul tak? So option A, option B, in and out of phase because ialah interference kan, destructive and constructive. But why is it loudness and not pitch? So that is my question to you. Macam dalam group sebelum ni, tak semua yang jawab. Semua macam seorang dua jawab, cukup lah kan. But actually I look at all the answers tau. So tak ada yang bagi jawapan sangat. So why is it loudness and not pitch? So answer in the comment section below. Nanti saya akan tengok jawapan, tengok siapa yang betul dengan siapa yang salah. Kenapa jawapan dia loudness dan bukannya frequency? Alright. Question number 3. The graph shows two waves. So which statement is correct? Both waves have a constant phase difference. Yes, because if you observe, dia guna phase difference bukannya guna path difference. So kalau kita tengok kat sini, coherent, so dia nak menguji your definition on coherence. Kalau kita nak tengok, the definition of a coherent adalah two waves that have constant phase difference and they are out of phase. They are not in phase. Kalau in phase maknanya sama lah kan. So if two waves are coherent and in phase, this would indicate that they are exactly the same waves. That means no phase difference at all. Constantly no phase difference. So they are coherent but in phase. Tapi in this case they are coherent but out of phase. Sebab dia punya frequency different. So the answer is B. Sebab apa? Kalau kita tengok kat sini, where do we define the phase difference? The phase difference is actually defined dekat the difference between the period lah kan. Kita tengok kat sini, one full period of the rate wave is here. So this is the period, yeah. But for the blue wave, kalau kita tengok, originating from here until here. So the point where we have a phase difference is actually between these 2 points. Okay, I'm not sure why my pointer is not working smoothly. Okay, dia dah pancit kot. Okay. So kat sini lah dia punya phase difference. You can check out my other video. I actually drew the comparison between the red and the blue wave in order to define which is the phase difference. And you can notice that the phase difference is the phase differences throughout the time are constant. Okay, question number 4. A student sets up an experiment to show interference of light. He uses two small red LEDs as the light source. Which of the following explains why he will not be able to show interference? So it's all a matter of coherence lah Betul, coherence. Two independent LEDs will generate two independent rays that might not have a constant phase difference. Thus, the coherence is compromised. Since coherence between the two waves is a prerequisite for interference in an ideal experimental environment where we can observe the interference clearly. Cuma kalau tak ada coherence, maknanya dia punya phase difference haywire, semua pergi kat tempat-tempat lain, kita tak nampaklah dia punya interference dengan cantik. There is going to be another question dekat subjective punya part yang dia define kan, the definition of coherence. So kat situ ada illustration, we will discuss further on the concept of coherence later. Okay, question number 5. An experiment is set up to demonstrate interference from different types of electromagnetic radiation. So this question is asking which type of radiation will produce fringes which are the closest together. So here you have to recall the order of electromagnetic spectrum along with its wavelength lah kan, wavelength and frequency. So you nak hafal dua-dua boleh, you nak hafal salah satu pun boleh, then kena convert manually. So recall the electromagnetic spectrum. Waves that have shorter wavelengths would produce closer fringes. Why? Why does this statement says waves that have shorter wavelengths would produce closer fringes? Why? So we look at the equation. Y, which is the length of the fringe, is equals to lambda d, which is the distance between the slit and the screen. Kalau kat sini photographic film. And small d is the size of the slit. So y is proportional to lambda. The smaller the lambda, the smaller the y, the closer the fringes. So the answer is D. Why is it D? Because D has the ultraviolet radiation has the shortest wavelength compared to the other wavelengths. As you can see here, ultraviolet kat sini, blue light kat sini, infrared radiation kat sini, red light of course is right after infrared. Okay, alright, any questions so far? I'll review that answer tu nanti okay, moving on to the subjective question. There's only 16 of us so maknanya mana lagi 3 tak tahu 3 masih lagi ada tu ataupun boleh tidur pukul 4. Siapa yang tak solat Zuhur lagi digalakkan untuk solat jangan lewat-lewatkan. Okay, mungkin 3 orang tu pergi solat Zuhur mungkin. Proceed. Describe what is meant by diffraction of the wave of a wave. So yang ni kita dah buat. Spreading of waves after passing through an aperture or meeting an obstacle. Part B, electromagnetic radiation of frequency 7.5 times 10 to the power of 9 Hz is directed towards a slit of width 6 centimeters. Determine the wavelength of the radiation. So we are given the frequency. This is not the wavelength. This is the width, 6 centimeters. So frequency is 7.5. Okay. So what is the wavelength? Macam kita nak buat, kita tahu dia electromagnetic radiation. So kita recall V is equals to 3 times 10 to the power of 8. So yang ni, walaupun dia tak bagi, dia bagi dekat awal lah kan. So V equals to 3 times 10 to the power of 8 meters per second. Frequency 7.5. You get lambda as 4 centimeters. Okay. Cara nak jawab ialah you kena tahu dia punya speed of light, which is actually given dalam you punya final nanti kan. Cuma untuk test ni apa semua kita tak bagilah kan, just nak biasakan. Oh, terkejut sekejap tengok Allah is watching. Memang betul lah kan, Allah is watching everyone. Innallah ma'akum, innallaha ma'ana. B2. Yes, explain whether the radiation will be diffracted at the slit or not. Yes, there will be diffraction at the slit since lambda is less than D. With D equals to 6 centimeters, lambda is equals to 4 centimeters. So the difference is actually lambda over 2. But it only occurs with a poor spreading. Sebab kalaulah dia punya wavelength is smaller than D, so dia akan berlaku juga diffraction. Cumanya diffraction tu akan berlaku pada kadar yang rendah. Okay, so poor spreading diffraction. Moving on. Okay. Okay. Explain what is meant by coherent sources. So these are, ni ada dua type of coherent and incoherent LED lights. As you can see, kalau kat sini dia macam tak adalah exactly true kan. So this is just a monochromatic LED monochromatic monochromatic signal. Kalau kat sini dia macam not to say constant phase difference, dia memang exactly the same lah kan. Tapi tak apa. Coherent are wave sources that have constant phase difference between each other. So this is the formal schematic jawapan lah. So that's enough lah kan. Cuma to explain this, you can have this laser light as coherent. Okay. Kalau dia ada phase difference tapi it is constant throughout, we can still observe interference after it passes through the diffraction slit. Okay. Kalau dia punya answering Arif punya question, kalau dia punya lambda ataupun dia punya wavelength is equal or smaller, dia kata, soalan dia kata apa? Bukan kalau nak diffraction gap kena equal or smaller. Yes. Kalau kita nak diffraction yang cantik, dia akan equal or smaller. Tapi kalau dia besar lagi, apa jadi? Akan ada diffraction but poor spreading. Okay. Dia akan jadi poor spreading. If anyone can quote the slides yang perbandingan tadi tu, you can actually post it dalam Telegram group untuk nak our reference lah. So this is coherent laser light. So if you do not have a constant phase difference between any of the lights, any of the waves, so we won't observe interference after it passes through the diffraction grating ke slit or whatnot lah. Okay. Yes, akan ada diffraction but not so obvious. That's what we term it as poor spreading. Now, question 8. The diagram below shows the displacement time graphs for two waves A and B. What is the phase difference between the two waves? Okay. So, ini straightforward. Okay. Question part A, part B, each of them give you 1 mark. So, ada yang careless. Mungkin dia nak jawab 180 degrees kan. Cuma dia tertulis 2 pi ke ataupun dia jawab 360 ke. Dia nampak dia faham, cuma dia tersilap. Okay, sebab kita tengah stres. Okay, tak solat lagi ke ataupun tak baca Quran ke contoh kan. So the phase difference is 180 degrees and pi radius. Do not forget the units. So kalau dalam hidup ni kita ada dosa-dosa besar kan. Dosa-dosa besar membunuh kan, memfitnah dan sebagainya kan. So kalau dosa besar dalam menjawab soalan exam ialah tak letak unit. Okay. The two waves A and B are combined. So superposition lah kan. Name the type of interference that will occur. The answer is destructive interference. My question to you, for you to answer in the comment section. Destructive interference kat sini, dia akan sampai kosong tak? Adakah dia punya amplitude, the overall amplitude after after destructive interference will become 0? Okay, the answer is no. Yes, because dia tak exactly the same kan. So amplitude tu akan ada. Amplitude tetap akan ada based on the profile of wave A. Tapi it's not really that high lah kan. So wave A tu dia akan kena tolak kan. Wave A tolak wave B. So, tapi dia masih lagi ada, kita panggil small ripples lah ya. Okay. Thank you for very much for those who answered. Question 9. The diagram below shows an arrangement used to demonstrate the interference of water waves. Yang ni frustrating jugalah sebab ada yang buat careless mistake. Banyak juga daripada group ni yang buat careless mistake. I'm not sure why. Okay, part A, constructive interference. Dia dah cakap kat sini kan, constructive interference, betul? constructive interference occurs at point A. So dia ada dua dia ada point A dengan dia ada point B. Where is point A? Point A is here. Point B is here. Okay. What is the distance between S1 and S2 to point B? We know the distance. Do we know the distance between point S1, S2 to point A? No, we do not. So, what is the path difference of the waves from the gaps S1 and S2? So, no calculation is involved here. It's all a matter of gauging. Do you understand the concept of constructive interference kat sini? So, the answer is, for a double slit case, any constructive interference that occur would give a path difference at multiples of n lambda, where n equals to 0, 1, 2, 3 and so on. Sebab kalau dia punya phase difference, path difference dia kosong, maknanya dia meet exactly the same lah kan. Cuma between S1 and A, kita ambil kan, S1 and A, then this is the first wave. Kalau S2 dia nak pergi ke A, dia akan ada lagging sikit, betul tak? Dia lambat sampai ke A. So the definition of path difference ialah how slow ataupun how lag S2 nak sampai ke A compared to S1 nak sampai ke A. So kalau constructive interference, dia kenalah within the multiples of 360 degrees. Kalau phase difference 360 degrees kan, which is actually the exact wavelength kalau kita compare to path difference. What is the difference between path difference and phase difference ni? So kalau kita tengok, kalau kita ambil phase kalau kita define phase difference, that means we are playing with the period. So we have to use dia punya time graph. Tapi kalau path difference, sorry buruk, so kita tekan-tekan je, tekan cursor ni. This is not my actual handwriting. My handwriting is much more better than this one, right? Isn't it? So jadi dia adalah distance. Okay. So it must be the wavelength. It is not the phase. Kalau you jawab 360 degrees ataupun pi period time, it's not accurate lah, sebab dia memang exactly nak path difference. Okay. So kalau constructive, dia kenalah in multiples of n pi. N lambda. Okay. Kalau dia minta phase difference, so the phase difference is in multiples of n pi, n 2 pi n. Okay. Part B. The water waves have a wavelength of 3 centimeters. Determine the path difference for the waves arriving at point B. Yang ni lah yang baru you guna the information kat sini. Memang 50% of you tak dapat nak jawab soal ni. I don't know why. Confused kot kan. Point A, point B tak nampak kan, sebab tengok guna phone kan, kecil. Kalau dalam kertas besar dia macam besar sikit kan. So path difference is 1.5 centimeters. Then the type of interference taking place at this point. So how do you want to prove it is a destructive interference? You prove it by showing that since the path difference is 1.5 centimeters, it is actually half the original wavelength. So it's it's lambda over 2. Okay. So ini tak ada apa-apa lah. Abaikan yang tu. So thus at point B is destructive interference. Okay. Right. Moving on. Question number 10. A microwave source is directed towards a metal plate with 2 narrow vertical slits. The receiver is slowly moved along the line XY as shown in the diagram. Okay. Soalan daripada Ikmal. Kalau jawab 1.5 cm dapat 1 mark. Yeah, you should get 1 mark lah. 1.5 cm for the second part lah kan. Kalau jawab 1.5 cm for the first part, memang tak dapat lah kan. But for second part, you should get one additional mark there. Okay, question 10. Explain why the receiver registers a series of maxima and minima. It's a 3-mark question. So taklah dengan jawab interference terus dapat all 3 kan. So you have to elaborate lah kan. Okay, first you have to describe the original wave transmitted by the transmitter. The transmitted microwave gets diffracted at 2 vertical slits, causing diffraction between the 2 coherent sources from at the 2 slits. Okay, from at the 2 slits je lah kan. Maknanya dia kena tunjuk dia daripada single source. So bila single source dia akan jadi coherent, dia akan lalu dekat diffraction slits tu, dia ada 2 slits tu, so dia keluar. So bila keluar tu dia akan jadi 2 coherent sources lah, based on which principle lah. Write down in the comments. Okay, Iqmal nanti you refer kat saya nanti saya check balik. So bila the same source lalu the diffraction slit, dia akan jadi 2 source. Which principle tells us that this is possible? Write down in the comments. Okay, and then what happens bila source tu dia diffracted? Apa yang akan berlaku ialah interference. Okay, interference between the 2 waves causes both constructive and destructive interference alternately at each antinodal and nodal lines, where at the antinodal lines you have maximum signals occur respectively and minimum at the destructive interference. Okay, so here you will get all three marks lah. Let's go. Part B, the adjacent maxima. Okay, so dia suruh cari the adjacent maxima lah kan. Why? Which is kalau ikutkan kat sini ialah dia punya fringes lah kan. But this is a sound wave. Dia this is a microwave, so dia tak adalah ada fringe yang kita boleh nampak kan. Cuma kita guna receiver tu untuk nak tahu. So lambda is equal to dy over d, small d over capital D. Okay, y equals to d lambda over d again. So d capital D apa semua kan. Substitute the values, you get 56 centimeters or 0.56 meters. Okay, watch out for the units, you get all 3 marks. If separation between the slits d is half, what happens? Then the adjacent maxima doubles to 112 centimeters since y is inversely proportional to the size of the slit. The smaller the size of the slit, the longer the adjacent maxima will be. So dia akan lebih membesar lah kat situ kan. Dia punya kita tak nampak lah kan. Cuma kalau dia adalah light wave, so kita akan nampak fringes dia tu semakin panjang. C part 2, if distance between the slits and the receiver D is double, it becomes further. From here it becomes further. What happens? Of course, adjacent maxima will also double since y is proportional to the distance between the slit as well as the screen. Kalau if it is a light wave lah kan. So this is macam kita main dengan projector kan. Macam mana kita nak besarkan besarkan gambar projector, dengan kita semakin dekat ke skrin ke ataupun kita semakin jauh ke skrin. Of course kalau kita jauhkan, dia punya gambar tu semakin membesar kan. Lebih kurang lah, lebih kurang. Alright, can we use different letters? Yes, you can. Okay, maksudnya apa? Use other terms kan. Kalau guna yang consistent dengan notes, it will be very much helpful lah kan. Okay, question 11. This is the distribution of the marks. Question 11. Monochromatic light is incident normally at a diffraction grating with 60 lines per millimeter. The 10th order maximum is observed at an angle of 19 degrees. Determine, bila dia dah masuk soalan ni 11, 12, dia ada berapa soalan semua 12 je kan? Ke berapa? Bila masuk soalan ni dia dah mula mencabar lah kan. 60 lines per millimeter lah pula, apa benda kan, diffraction grating pula tu kan. Okay, tak apa, bear with me. The spacing in meters between the centers of the adjacent lines on the diffraction grating. So dia nak tahu jawapan dia kat situ. So determine. So spacing between the centers of the adjacent lines on the diffraction grating is given by the formula. Not really a formula, it's actually a concept lah kan. You are given the diffraction grating 60 lines per millimeter. So kalau kita ada 1 millimeter, dalam diffraction grating tu ada berapa banyak line diffraction grating tu. That is the value. Kalau ingat balik kalau ingat balik kita punya tutorial hari tu, is the other way around, betul tak? Kalau ingat balik dalam tutorial hari tu, so within 1 millimeter, let's assume that this length is 1 millimeter. So this is 1 millimeter. So dia kata within 1 millimeter, how many lines, how many diffraction grating lines? So dia kata diffraction grating tu apa? Diffraction grating tu line very small lines in which light can go through it. So very small. Macam you kalau an example of a grating kan, you take your hands macam ni kan. So you buat face palm sikit kat sini kan. So you look closely between your between the slits lah kan. So this is a very typical example of a diffraction grating kat situ. So here you tak boleh nampak lah kan, tapi if you pass through a light kat sini, nanti you akan nampak lah, you punya light tu, the light that goes into your ear, the eyes tu, dia akan diffracted somehow. You akan nampak ada line kat situ. Tapi yang ni dia punya diffraction grating ni, dia punya line tu besar lah kan. This we are talking about berapa milimeter. Berapa milimeter. So dia nak tanya the spacing between centers of the adjacent line. So kalau kat sini dia macam besar lah kan, just one line kan. So imagine if this is very small, so the D value is what? Just the inverse of the number of lines per millimeter, which is the kita nak tahu berapakah berapakah panjang this one between one line to the other. So this is the value of D, which is very small. So D is equals to 0.0167 millimeters, which is equals to 1.67 times 10 to the power minus 5, which you can actually convert it straight away by putting 10 to the power of minus 3 on top. Okay. Part B. Given the diffraction grating equation, what is the diffraction grating equation? D sin theta n is equals to n lambda. Okay. What is the wavelength of the incident light? So it's just a manipulation of this equation. So question 11, 12, 13, 14, main dengan equation ni je sebenarnya. Okay. Yang mana D ialah constant, lambda pun constant. Yang berubah-ubah ialah theta dengan n. So dia 3 to 4 variables sajalah kan. Okay. So plug in into the equation. Dia kata kat sini berapa order? N is equals to 10. What does it mean by n equals to 10 kat sini? So diffraction grating, kalau kita tengok, let's say for example this is the source. This is the diffraction grating slits lah So let's just change colors. Okay. So if you have, this is the zero order kan. Okay, my laptop dah mula unresponsive dah kat sini. So this is n equals to 0. N1 is what? N1 is happens at angle theta 1. N2 happens at what? Angle theta 2. And then sampailah theta 10. So this is n equals to 10. Okay, you get the picture lah So n equals to 10. So dia semakin besar. So kat bawah pun akan ada. So dia double saja. Kalau dia adalah white light, so dia akan bagi spectrum. At each order dia akan ada spectrum of light. The 7 colors of rainbow tu at every order akan ada. Okay. So here, plug in the numbers. D equals to 1.67 times 10 to the power minus 5. You got this from the previous question A. Sin, what is the value of theta when n equals to 10? It is 19 degrees. So the value of lambda is 5.4 times 10 to the power of minus 7 meters. Quite straightforward, isn't it? Senang je. If you know how to do it lah kan. Boleh insyaAllah. Is it equally spaced? Are you referring to the diffraction grating? If you are, then it is. So dia equally spaced, dia punya diffraction grating tu maknanya dia punya spacing 0.0167 mm tu, dia akan make up the entire diffraction grating lah. But if you are referring to the angles, no, it does not. It is not equally spaced kalau dia punya diffraction angle tu. Sebab apa? Because we are using sin theta. It is not directly proportional. Dia proportional only to the order and the sine. The order and the theta is proportional to the sine of the theta. Okay. This is the distribution of marks. For you to know the value of theta, you can actually plug into your calculator. Cuba buat untuk n equals to 1, 2, 3, 4 and so on. Okay. Alright, question number 12. Yellow light of wavelength 5.5 times 10 to the power minus 7 is incident normally on a diffraction grating. Memang diffraction grating sajalah sampai towards the end of the paper, the end of the quiz. With 300 lines per millimeter. So if you know is 300 lines per millimeter, get the value of D. Okay. Calculate the angle between the first order and second order maxima. Okay, Iman tanya what's the maximum value of N. You will get that question in question number 13. The maximum order. You are asking what is the maximum value of N, maknanya what is the maximum order. So that you sabar question number 13, insyaAllah. So kat sini dia kata calculate the angle between the first order and second order maxima. So kita tahu this is N equals to 1. This is N equals to 1. And this one is N equals to 2. So given lambda is given, mashallah, diffraction grating, you nampak je 300 lines per millimeter, take the inverse, you get 3.33 times 10 over minus 6 millimeters. And then, of course, you kena convert lah kan. Using the diffraction grating equation, d sin theta n equals to n lambda. Kita nak cari apa? The angle for the first order maxima. So n equals to 1. So macam nak buat? Plug into the values. N is equals to 1. Lambda is given. D is given. D is not given actually. D you have already calculated. Take the arc sine of it. Take the arc sine of the fraction. And you get the value is 9.5 degrees. If you actually key in your values correctly in the calculator lah kan. Tapi kalau setting radian, lepas tu kelang kabut radian dengan degree, memang rosak lah kan. I had that one particular experience. Tersalah setting calculator tu semua radian. Sebab tu all the values semua funny values keluar. Times 10 to the power minus something lah apa semua kan. So make sure your calculator is set properly lah kan. And then for the second order maxima, n equals to 2. So theta 2 is equals to 19.3. You repeat the same thing, which is what? Which is playing around with the equation. This equation. Diffraction grating, always remember d sin theta n is equals to n lambda. Okay. Just nak tahu dia punya position kat mana. Okay. So kalau you ada sound wave, dia diffract, so you nak designkan you punya rumah contohnya untuk nak dapatkan position mana yang ada suara, yang mana yang tak ada suara and what not, you can actually use this concept. Okay. For second order maxima, you get the value. Siapa yang jawab setakat ni, dia tak dapatlah dia punya full mark kan, because the question is asking the angle between the first order and second order maxima. So the angle is 9.8 degrees. You can check out my other video. I drew an example of angle ni sebenarnya kat mana. Kita nak cari angle apa. Okay. Saya promote video yang sebelum ni kan. Tak tahulah. I'm not sure whether senang kita jamakkan dua group pada satu ke ataupun buat this group separately. Sebab tapi ialah problem dekat jadual waktu lah kan. Okay. This is the distribution of marks. Okay, proceed to question number 13. Ni soalannya Iman tanya lah kan. What is the limit for n? Okay, blue light of wavelength 4.5, 10 to the power minus 7, incident normally at a diffraction grating with 100 lines per millimeter. Calculate the maximum number of orders that can be observed. Okay, so hadis dia kata 9.79 degrees. So dia ada plus minus lah kan. It's all matter of precision. Berapa banyak you letak, berapa banyak yang you bundakan and what not. So kalau siapa yang rasa terkurang markah tu, you can PM me, DM me, nanti kita tengok. I can just look back at your marks. So dia kata, okay, incident normally at diffraction grating with 100 lines per millimeter. So kalau 100 lines per millimeter, dapatlah value D is equal to 1/100. Straight away. Calculate the maximum number of orders that can be observed. This is very interesting. So lambda equals to this one, diffraction grating, buat benda ni, dapat markah free insyaAllah. Using the diffraction grating equation, D sin theta n equals to n lambda, betul? Okay. Maximum number of orders. So if you can review the concept of diffraction grating kat sini kan. Okay. So let's say this is your screen lah and you have your fringes kat sini. Kan? Okay. So kalau kat sini kalau you tengok, let's say we use another color, use a dark blue. So if the line passes through at the end equals to 0 order, so yang ni dekat tengah-tengah lah kan. So dia akan pergi increase, n equals to 1, n equals to 2, n equals to 3. So soalan dia, n ni dia boleh sampai besar mana? Berapa banyak n? What is n max? Okay, Allah susahnya nak tulis. What is the value of n max? Subhanallah. Okay. What is the value of n max? Untuk kita nak tahu dia punya theta. So kita tengok theta kat sini. So how do you go about this? First you define the diffracted light ataupun the diffracted wave. What is the maximum angle that it can go to? Kalau kita kira dia punya angle tu daripada n equals to 0. We increase kan? 0, 1 degrees, 2 degrees, 15 degrees, 45 degrees. Berapa banyak dia akan pergi? Berapa banyak dia akan pergi sampai maksimum dia berapa? It should be 90 degrees, betul tak? Sebab any more than 90 degrees, it will give an indication that it is some sort of a reflection ataupun a refraction. It's not diffraction kat situ. So dia sampai 90 degrees, that is the maximum number kan. So here n, you substitute theta n which is equals to 90 degrees, which is theta n maximum. So you get 22.2. So this is the maximum number of orders that you can have. Why is it 90 degrees? Because you can't get a refracted wave kat belakang kan. Because the grating is here. This is the grating. If somehow light tu dia boleh lari ke belakang, yang tu dah jadi pelik lah kan. This is not diffraction lah kan. If that, kalau main dengan prisma, jadi lain lah kan. Tu refraction lah kan, the angle and whatnot. But this one is, the diffraction is normally to normal to the wave kat situ. So that is why dia punya angle is maximum at 90 degrees. So it can't go back. Dia taklah macam apa radiation, yang mana radiation ni dia boleh bersepah-sepah pergi mana-mana kan. Radiation macam X-ray ke apa-apa kan. Bila kita blast elektron tu, terus dia pecah, dia akan pergi kan. Itu cerita lain lah kan. Tapi yang ni just a normal coherent source going through a diffraction grating. So dia akan diffract kat situ. Ada tak yang boleh pergi ke belakang? No, it's not possible. So dia maximum tu dekat 90 degrees. Kalau dalam kes lain tu, elektron apa semua tu, itu cerita lain, radiation apa semua tu. Okay. So the answer is 22. For those of you who answered 45, you got it wrong lah. Why? Because dia atas dengan bawah tu, dia macam mirror saja. So dia sama saja. Sebab dia tak kira n daripada bawah sekali kan. Dia kira daripada tengah. Daripada tengah, lepas tu dia proceed diffract. Dia macam butterfly lah kan. So kat situ lah. Alright. Question number 14. Okay. Last question. Bertahan lagi ya. Question number 14, dia ada two parts, part A and part B. Answer the following questions with supporting calculations. You are given a diffraction grating with 40 lines per millimeter. Daripada progression 11, 12, 13, 14 tu dia punya diffraction grating tu semakin semakin sikit kan. The diffraction grating is mounted on an instrument that can measure angles to within plus minus 0.1 degrees. Kalisha ada soalan, kalau kita dapat 22.8, kita nak round off kat mana? Jawapannya 22 juga lah kan. Dia tak boleh lah macam tiba-tiba wujudkan 23, 0.2 orders. So dia ambil yang minimum. You take the floor ataupun you take the nombor yang lebih kecil, because it's not macam a round value macam tu saja. Alright. It is mounted in an instrument. Can this instrument be used to determine the individual wavelengths of spectral lines of wavelengths 589.6 and 589.0 nanometers? Determining the individual wavelengths of spectral lines. So maksud dia apa di sini? Kita ada satu source light. So dia akan pecah. N equals to 0, N equals to 1, N equals to 2, sampailah N maximum kan? Betul tak? Kita tahu N maximum tu berapa kan? Tapi kalau kita nak tahu N maximum tu, kita just letakkan theta equals to 90 degrees. So kita boleh tahu dia punya maximum order tu berapa. Cuma dia nak kata individual wavelengths of spectral lines of wavelengths 589.6, 589.0. So kalaulah dia kata spectral lines kan, maksudnya apa? Within the source, dalam source ni dia sebenarnya ada dua wavelength. Okay, dia ada dua wavelength. So maknanya kalau kita tengok dekat dia punya screen kat sini, dia sepatutnya akan bagi dua wavelength yang dua wave ataupun dua points, dua fringe yang represent different wavelengths. Okay, kat sini. For each order. Okay, to understand this, let's just review if we had a visible light. If we had a visible light, that means that particular light ada an entire spectrum of wavelengths, betul tak? Daripada merah jingga Michael Jackson kena halau balik India Utara. Merah jingga kuning kena halau hijau balik India Utara kan. Biru, indigo and ungu lah, violet lah kan. Okay, you've got that seven types of waves. So dia ada, each one of them ada dia punya wavelength values, and it's not, dia taklah nak kata continuous, dia discrete, tapi dia ada range of values lah kan. Although initially dia ada just one white light kan, white light, tapi bila dia masuk diffraction grating, dia akan pecah kan, ikut order. So order tu, each order dia akan ada spectrum dia, betul tak? Dia ada spectral lines, kita panggil spectral lines with different wavelengths. Smaller wavelength akan dia akan jadi closer to the center. Semakin besar, semakin panjang wavelength dia tu, dia semakin jauh daripada center. So for every order tu akan ada dia punya spectrum lah, spektrum cahaya tu kan, which is actually the next question, dia akan tanya benda tu. Tapi untuk kita nak faham this question, maknanya individual wavelengths of spectral lines of wavelengths tu dia ada dua, 589.6 ataupun 589.0 nanometers. So in order to answer this, first kita carry out the most obvious one lah kan. Kita calculate the diffraction grating spacing. The spacing is equals to D is equals to 10 to the power minus 3 divided by 40. Kenapa 10 to the power of minus 3? Sebab kita nak convert terus automatically millimeter kepada meter. Kalau question 11 tadi kita buat manually lah kan, kita separatekan dua. Cuma ni soalan yang memang dah soalan-soalan membunuh lah orang kata kan, terus bagi 6 markah sekedebuk kan. So D is equals to kita just ambil the inverse using the diffraction grating equation. We know this one, just state it out, the obvious. Now we are given what? Lambda 1 and we are given lambda 2, betul? And kita nak tahu instrumen ni boleh tak nak measure dia punya angles kan? Dia nak measure dia punya angles between lambda 1 and lambda 2. So now if we take the maximum, okay, maximum, sebab maximum tu dia akan bagi tahu this is the most dia punya most besar punya difference lah kan. So bila dia minta untuk nak tahu can they measure the angles to determine the individual wavelengths or spectral lines, we have to look at the maximum order of diffraction where theta is equals to 90 degrees. So either we just assume the higher wavelength will give the higher the smaller wavelength will give the higher order, or we can actually just use it manually. So kita akan tahu both of them will give the maximum order is 42. Alright, so kat sini dia kata 42 orders. So therefore the maximum diffraction angle at maximum order, that means kita ambil kat sini. Okay, so kita nak tahu instrumen ni dia boleh tak nak detect this difference angle theta. Boleh tak dia detect both wavelengths of wave bila dia dah diffracted at the maximum order. So kita tengok theta 1 at the maximum, which is 42, is equals to 81.7 degrees, and theta 2, sorry, that one is theta 1, this one is theta 2 at 42, order 42, it is equals to 82.1. So if you subtract, the difference between the two angles are 82.1 minus 81.7, it is equals to 0.4 degrees. So here you can conclude, since the accuracy of the instrument is plus minus 0.1 degrees, it is less than 0.4, so it can actually determine the individual wavelengths of the spectral lines of the wavelengths between these two waves. Oh, faham ke tak faham? But this is how you do it lah. Okay. Menarik juga kan bila tanda tu macam-macam jawapan dapat. Ada yang ambil n equals 1, tapi n equals 1 kat sini saja kan. The spacing is not really that apparent lah kan. But it's okay, we still can discuss. InsyaAllah macam mana. Trying to absorb. Alright, thanks. Moving on, we've got 5 more minutes. 14B. This is a gambar yang lebih senang nak tengok kan. So dia kata white light is incident normally at the grating. Estimate the angle between the extreme ends of the spectrum for the 10th order maxima. 10th order maxima kita ambil kat situ. Okay. So macam ni lah sebenarnya dia punya gambar kan. So dia akan diffract, so dia akan ada spectral lines kat sini. So this is one spectral line, this is another spectral line. Okay. Okay. So extreme ends of diffracted white light spectrum. So dia kata estimate the angle between the extreme ends of the spectrum for the 10th order maxima. So kat sini kita tengok kalau kita zoom in lagi. So here the spectrum dia punya extreme kat mana? Dia punya extreme dekat red light dengan red light dengan violet. So what is the average ataupun the standard what is the standard wavelength of a red light and a violet light? So red light kita just boleh estimate 700 nanometers, violet as 400 nanometers. Tapi adalah range value lah kan, 740 ke 430 ke, it all depends. Yang menariknya, question 14B ni is completely isolated from question 14A. So if you cannot answer 14A, you should be able to answer 14B, given that you understand the concept of diffraction kat sini lah. Okay. And then for 10th order maxima, notice that you use the same formula, betul tak? You use the same formula, d sin theta is equals to n lambda. Plug into the values, you get the respective angles. So you cari dia punya difference. Difference of theta is equals to 7 degrees. So this is the answer lah. Wallahu a'lam bissawab. Okay, tu je. That's it. End of the slideshow. Click the exit. Straightforward lah kan sebenarnya. Cumanya mungkin sebab tak biasa buat soalan-soalan macam ni, so terkejut lah kan. Sekali bak dapat pula 4 soalan kan. Itulah orang kata kan, you have to try. Okay, why is it the 10th order? Because that is what the question asks us to do. If you read back the question, dia kata estimate the angle between the extreme ends of the spectrum for the 10th order maxima. So dia bukannya you tak boleh nak buat tau. Dia lebih pada sama ada you tak biasa ataupun you baca soalan silap. You salah baca soalan. Okay, so nak ceritanya dalam kehidupan ni ada benda-benda yang kita tak biasa buat, bukannya bermaksud kita tak boleh buat. Dia lebih pada sebab kita tak pernah buat. So bila kita dah buat, then kita bolehlah buat kan. Contohnya macam Ramadan kali ni, nanti selalunya orang, biasanya orang Melayu lah kan, kita selalu nak galakkan orang untuk nak khatam Quran. Tapi kita tak biasa buat. Bukan bermaksud kita tak boleh buat kan. Sedangkan kalau kita baca Al-Quran tu, the reward is multitudes of rewards kan. Dia akan berganda gila-gila kan. So itulah ceritanya. So yalah, understanding pun kan, that is our problem lah sebenarnya. Language lah, lebih pada language kan. Contohnya if you observe my other video tu, half kan, macam mana orang putih define half kita kan. Half ni 1/2 lah kan. But what about 1/2? So ada kita assume 1/2 ni lah 3/2 lah kan. No, 1/2 is actually half. It's a half. 1/2 kalau you baca soalan tu 1/2. No, 1/2 is 1/2. Okay. Okay. Dia kata like at first, Kalisha is asking the question, number 14 part A lah kan. Okay. We find the order when angle is 90 degrees. Then we find the angle again. Isn't it 90 degrees? No, it's not. It's not going to be 90 degrees. It is actually similar to answering the question of the maximum number of orders. Kan? The maximum number of order is 22. Dalam question yang sebelum-sebelum ni kan. If you look back, sebenarnya soalan-soalan yang dia dah pening-pening dah. Contohnya macam ni kan, kita setkan angle dia at 90 degrees and then we find the order. Tapi kalau kita tengok yang ni, sorry, so if we plug in n equals to 22, you masukkan balik n equals to 22 dalam dia punya equation, and you try to get the value of theta kat sini. You akan dapat theta berapa? Theta dia akan dapat, it's not 90 degrees. It won't be equals to 90 degrees. It will be lesser than 90 degrees. Sebab apa? Kalau kita theta ialah equals to 90, dia akan dapat 22.2 order. So sebab tu kita round off kan. Kita round off kan, dia akan jadi 22 order. So bila kita ambil 22 as the integer, we won't get theta equals to 90. Probably we get lesser, probably 80 degrees. So maknanya diffraction tu dia akan pergi sampai tahap angle dia lah 80 something probably. Tapi it cannot be more than 90 kat situ. Alright. So it won't be 90 degrees again. Right. So itulah dia. Understanding, biasa buat, insyaAllah boleh. So that's it. For now, insyaAllah. See you guys in Telegram. Apa-apa perbincangan nanti kita akan buat kat situ. Wallahu a'lam bishawab. Aqulu qawli hadha wa astaghfirullah li wa lakum. Inshallah, we'll end our session with tasbih Quran and Surah Al-Nas. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal asri innal insana lafi khusrin illa alladhina amanu wa 'amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.